Desk of LadyAda.
Hey everybody, and welcome to the Desk of LadyAda, our stream that we do every Sunday night at around LadyAda o'clock, which can vary from about 8 to 10. Yeah. It's me, LadyAda. With me on camera control is Mr. LadyAda.
Yep.
He's the voice of reason behind the scenes. We've got like a bunch of stuff to show. That we weren't as productive, of course, as last week's 4-day weekend, but we did get a bunch of stuff done this week. So first, we want to kick it off with some mailbag.
Yeah.
Okay. Or some news. You want to give some updates?
Yeah, sure. We got some stuff that we're going to show off. Mm-hmm. We have some work in progress stuff. So how about you start off with the Lumen Couture LED face mask?
Yeah, we got this really cool face mask from Lumen Couture. This is from Chelsea.
Yeah,
Klukas.
show the little pamphlet thing on the overhead.
Okay, so this is the.
Yeah, so this is. So show the other side first. So this is a picture. You've probably seen this going around the internet. It's like, oh, cool, like Blade Runner face mask looking thing.
Yeah.
And then.
Yeah, so it uses an app.
Came with, yeah.
And if people demand, I can maybe take it apart next week. I just don't know if we have time to take it apart, because I think I have to take it apart and then look at it and then put it back together. But basically what it is like the Matrix portal, there's this LED matrices that I call them Hub 75s. That's the standard. It's basically one of those on a flexible. We even stock them in a flexible material, and there's a section that's routed out for the eyes. But it's basically just like, I don't know, like a 32 by 64 LED matrix, basically. And it's curved. It's on this flexible PCB. It's curved, and then it has a kind of diffusion LED on top of it. And then there's a little IR sensor here. And then there's a button at the top. And when you press the button, it tells you the battery state.
Yeah, and then when you press the button, it'll go through all the different faces.
Yeah, so
and that flicker is just because of the camera. It's not.
Yeah, it's actually not flickering in person. So you can wear it, and it'll have weird, cool animations.
Yeah, flip through them pretty fast. Go tick. I have the app on my phone, and I was playing around with it. And
yeah, that's
the one that everyone sees.
Yes, kind of weird. Gothy one. Zombie. Trying to reduce the reflection. So interesting Halloween-y mask, and I can see through these two little slits, obviously.
Yeah.
Not great, but enough. And then you can probably send custom animations as well.
Yeah, I'm gonna try that on the app.
And then there's also this distance sensor, which I don't know exactly what it does.
Yeah, when I was playing around with it, when you waved your hand over it, it would go to a different one.
I think it's
yeah, then
when you want to do face changing, the Chinese face changing magicians. This is kind of a digital version. They're just really fast. That they move these little thin fabric masks.
And someone wants to know, can you see out? And the answer is yes.
I can. There's these little slits you can see here, and they're clear. I can see through them.
Yeah.
Now I wouldn't necessarily do anything risky in it, because you don't have great vision, obviously. But you can definitely see. You can see, and you can move around and stuff.
Yeah.
And you can kind of wear glasses, but it's not great. I would definitely wear contacts if I was actually going to do something with this. This is kind of cool. It's almost certainly, because you can see that the slight refresh. It's some sort of Hub 75, continuously redrawn PWM signal. You do it over Bluetooth, so hopefully we can either reverse engineer or find the Bluetooth algorithm, and then or protocol, and you can then send your own data to it without using an app, which I think would be kind of cool. Maybe have sensors that you could use a Bluefruit, and you could use a sensor. Instead of this button.
Yeah, if you need to hook up sensors like heart rate or put data on it and to show pulse oximetry, there's all sorts of fun stuff you could probably do with this. Okay.
Let's go.
So do you want to show your progress on some projects?
Yeah. Right, okay, that was mailbag.
Mailbag.
Okay, send us cool stuff you want us to show off.
Well, we bought this.
We bought this. Yeah. Okay, so another fun thing that we did this week is we merged in deep sleep support for the ESP32-S2, which is a really big deal. Because a lot of Wi-Fi projects, if Wi-Fi uses a ton of power, And you really need to go into deep sleep mode in between, or light sleep mode at least, in between getting data from Wi-Fi if you want to do anything with battery power, or your battery will just get like totally obliterated. With Bluetooth, it's important too. Don't get me wrong, but with Bluetooth, you're not using 700 milliamps, 800 milliamps, or 200. It's like there's little spikes, but Bluetooth is by its nature a lot lower power usage than Wi-Fi. So moving to the ESP32-S2, we definitely needed low power sleep, and we have merged low power sleep in. So it's available now in the latest beta version of CircuitPython for the ESP32-S2, and there's even an example script in the pull request. And the MagTag library has it as well. Currently, sleep mode is time-based, so you sleep for like up to a day. We actually have, our little coronavirus demo sleeps for one full day in between refreshes, and it's been going for like a week. Like every day at 8 o'clock, I'm go downstairs and look at the fridge, and it goes deep, deep, and it gets the data, and it goes back to sleep again for a full day. And that is, that's what allows it to run for so long, because you kind of get like 100 refreshes for the MagTag on a battery. So if you can put a day in between each one of those, it's like it can last up to 100 days, because it's the power used during the refresh is what takes up the most power. This week's INPI was this Nordic Pro Profiler kit, and so I actually got one. Maybe I'll show them overhead real fast. So you folks who have watched this show have watched me do power monitoring with a monsoon power meter. Monsoon power meters, they're totally great. They're wonderful. They have a really great user interface. I really still like the monsoon power meter. It does have a cool USB pass-through mode, which is something that this one doesn't do, where you can power something over USB and will also like pass through the data lines for you. So you're really just monitoring just the power used for USB. This is really meant for battery more than that. But this one is like a tenth of the price. It's like you're not going to get anything cheaper for the price. And also got this like cool translucent window. So we have one of these, and I reviewed it for INPI, and I've actually been using it for the low power use as well. So I'm using this as a power supply, because it can supply up to an amp, which is plenty. And then this is a power output cable, and then all I did is just kind of just shove 2 wires into the battery port. Power and ground from the battery cable going to the power connector, which go to the power profiler, and then I'm fully powering this circuit from the power profiler, which means I don't have to worry about, like, if you have anything else connected like USB, you could be like charging the battery, and like there's data, lines have leakage on them. No, this is purely powered from the battery. And then you can oh wow, this is
make it to the computer.
Well, yeah. Wow, libUSB error. This is cool. Yeah, let's go to the computer. And it uses libUSB, but I do. Okay, so you can connect to the device, and then you set the voltage output. So here you can select it like very precisely, but I set it 3.7 volts or 3,700 millivolts. See, that's like a kind of average battery. You turn it on like this, and you start sampling, and you can see the power. So it's 500 milliamps, and then it spikes up. It spikes up to almost 800 milliamp. That's probably when the Wi-Fi starts scanning. And then connecting, getting data, and then, I think here's where the radio gets turned off, and we're doing some activity, and then the final shutdown, and then this is the low power. And then the low power mode, what's interesting is it scales as you do the power. So you saw it was 50 milliamps and it jumped up, and so the scaling got higher. And then when it's in sleep mode, it's about 260 microamps. I'm probably going to eventually redesign this board, because now I know where that current is going. When I designed this board, I had some assumptions about where the current was being used. And some of my assumptions were right, but some of them were wrong. It turns out that you really want to completely disconnect the e-ink display. I thought the e-ink display, it sort of implied it was 1 microamp in sleep. And I sort of believed it, and it turns out that that's actually totally not true. It's about 100 microamps. And normally I don't really care, but in this case, that's almost half of my power. So definitely having full shutdown of the e-ink display is the next thing I'm going to do. And then maybe having a cuttable power LED. I like the power LED, but it does draw 40 microamps, which is, about a quarter of what I've got going on here, maybe a fifth. So we'll move that. And then about 100 microamps is the ESP32-S2 in sleep mode. So I do recommend, if you do anything with low power, to pick up one of these, because we have so many folks who contact us and say, how long will my project run on this battery? And I have to say, I have no idea. Like, here's a rough estimation, but whenever you're using Wi-Fi, you see it's spiky. You don't know how many spikes or how long those spikes are. How long is how long are you getting data? Is the data being cached? All these things are going to really affect your data, your power usage as you're getting data over the internet. So getting a power profiler, they're $80. Now, it's not super cheap, but it's a heck of a lot cheaper than they used to be. And this way, it'll actually tell you exactly how much power you're going to use, and you can calculate very easily how long your battery's going to last. So, strong recommendation from me. Is there any questions about low power stuff?
No.
Cool. All right, so moving right along.
Well, someone says, is e-ink that greedy for power?
The driver is, and I don't, the thing about the e-inks is like, you can, like, for example, I just cut power completely. It's like down to, 3 microamps, which must be just a leakage current, through the transistor that I'm using to power off the circuit. And it says 1 microamp in the data sheet, but like when I send the command, it's not 1 microamp. So, what am I going to do? It's like there's no contact for the company. There's no tech support. I don't even know the name of the company that makes this chip.
So if I measured this, do I have to remove the power required for the LED on the board?
Well, I mean, you can leave it. It's just like you're going to be including that in your power calculation.
Okay. Is the profiler in stock?
We don't stock it, but Digikey has it. I think they even have some in stock still.
Yeah. We did this on our Ion MPI video. You can check that out on YouTube and all places we post our videos.
Yeah, it's just called the Power Profiler Kit 2. It's about like $80 from Nordic. And if they're not in stock, sign up and they'll get more. I know that they got a shipment of like about 100 or so.
I think they sold a bunch after we did the video.
Yeah. Okay, cool. So,
all right, what's next?
Closing this off. So that's the low power stuff. So, the MagTag will last a while. But now that I know what to look for, there's a couple other things. Like, for example, I want to have like a proper battery. Like, I have this new LC 700943, whatever, battery monitor. I'm going to add that instead of a resistor divider. A couple little things here and there that'll just help with the current. Yeah.
Oh, thanks, Rodrigo, for supporting our show.
Oh, thanks.
Yeah, Bing. Will the Matrix portal update to the ESP32-S2 anytime soon?
Not anytime soon. Eventually, it would be cool. I do want to do like ESP32-S2 versions. I'll say the ESP32-S2 is not going to be as fast as the M4 plus ESP32 SPI for a lot of the Matrix portal use cases, which are not high data. It's like high computation. Like there's a lot of the M4 time is spent going to an interrupt mode and PWMing out those pin lines. So if there's a DMA way of doing it, yeah, maybe like it would make sense. But like right now we're using just a lot of computation of the M4 to give you that like very nice smooth refresh of the RGB matrix display.
Okay, and then Scar showed off the board in Discord. You can check that out later. It's an ESP32-S2 mini board. Okay.
Oh, interesting. I wonder if they're using ESP32-S2 FH4. Let's check that out on the overhead. So we just picked up some of these chips. These are fresh samples. So this is an ESP32-S2 FH4. I'm going to do what you do, which is zoom in as much as I can. You can do it. Nope, you cannot do it. Oh well, I tried. So this chip is an ESP32.
You can do it.
It kind of did it. Well, I wanted to get closer, but it just doesn't. I don't have the zoom in. Oh wait, maybe I do have it. Zoom. Wait, hold on.
You're thinking of the other overhead.
No, this has zoom. Look, I zoomed.
Yeah. If
So
you keep you out of the frame, you can flip it over and it won't refocus.
No, that's fine. It's locked. Okay. So the ESP32-S2 FH4 is a flash. The F is for flash, H is for high temperature, which doesn't really matter, but you know, I guess it comes in with the process. And it has 4 megabytes of flash built in, so you don't need a separate QSPI flash chip. Now it's not any faster; it's just like bonded together inside. Like it's going to have the chip, and then they have another chip for the flash, and they just run the wires together. That's almost certainly what's going on in there. And there's also a version like the FSH4, which has SRAM and flash built in, and that's available for pre-order on Digikey. I pre-ordered some. I don't know when they're coming in. I have no, you know, like Scott actually was the one who like saw this. I don't even know if it's announced yet, but basically you get an ESP32-S2, and this one has the flash built in, which is kind of nice. And it doesn't have the SRAM, the PSRAM, but maybe you can live without it. It has SRAM in it, just not like, you know, the whole 2 or 4 or 8 megabytes. And then there's a version that's coming out that will have flash and SRAM in it for $2. Maybe I'll quickly show that so people can sign up for it. It's like, I don't remember the exact part number. There's the S2.
I'm gonna go to the screen.
Yeah, let's see if I can see what it is. So this is the FH4. So if you want, there's 4 in stock. You can get them. And this is the one that has the flash inside of the chip. So it's like, you know, a little bit more expensive, like 30 cents, but it's basically the same price as if you just got it separately. And I believe it's the FR01. I believe this one has both flash and SRAM, and that's why it's basically like it's $2 per chip. And they say they're going to get them in about a week. I don't know if that's true, but you can back order these, which is what I did, so that when they do come in, because I'm definitely going to want to use this chip, which has the flash and SRAM, for making like an itsy bitsy ESP32-S2 or a cutie pie or like a circuit playground, because it's just the chip. It's like, it's so easy. Has the native USB, has the flash, has the SRAM. It's perfect for a little USB device. Yeah.
This is a question from Drew, but I think there's a video out now. Drew wants to know, how silly is it for contemplating turning an easy bake oven into an easy reflow oven? Liz, I think, just posted up a video, and we have it on our blog. I think someone just did. So
Liz is smart.
So it's definitely not silly.
You can do it. I mean, why not?
Yeah.
You just throw one. Okay, so that's the new chip.
It's a good idea.
So check out this new ESP. I like the all-in-one flash and PSRAM. Not, you know, it basically it's the same price. You have a fixed configuration, but you get to make it very small. I mean, like the PSRAM chips and the QSPI flash chips, they're kind of big, right? They basically double your physical size.
Is that pin compatible with the current ESP32-S2?
I think so. I don't know. I just got these yesterday, but I think it's the same pin out, and like those pins are bonded on the inside, so like you don't want to connect to them, or you can, but you probably just want to like leave them floating. Okay.
Do any of the ESP32-S2 support being powered from a USB 5-volt line if we want to make a USB gadget, or will you need a 3.3 volt LDO every time?
You always need a regulator. Okay. Always. Oh, every chip does. Sometimes regulators inside the chip, like the FT232RL or whatever, but you always need a 3-volt regulator because USB data lines are always 3 volts. Don't skip it. Some people try to, and it's not worth it. The regulators are like 5 cents. Don't be cheap.
All right.
Yeah.
What's next?
Okay. So that's the chips. Next up, I had this fun project that Jepler made me. Basically, I have employees, so I'm like, I want you to make me this thing. This is a Raspberry Pi, and all it does is play chill tunes. So I've got it playing. Hold on. This is. There you go. So this is the Braincraft hat, and it's got these speakers built into it. So it's like, I want to make I don't know if people remember this Buddha machine, but it was this nifty, like all-in-one, hacked, like sutra singing box from like Asia, I think Thailand or Korea, and folks hacked it to like play like weird ambient loops, And so I was thinking like this would be like the YouTube version of the same, where this is a Raspberry Pi and it just loads up a YouTube, one of those like streaming nonstop, like lo-fi, chill, jazzy background music thingies. And we have the joystick for audio. So it's just like playing some like jazzy music.
Yeah, quickly turn it off because the last time we showed this, YouTube flagged our video.
Oh, it did?
Yeah.
Okay. Well, believe me. So it plays audio.
And then special thanks to John, who's also just sent us some cash for doing this show. This is great.
I'm doing this.
Grocery money is happening.
So this is going to be a guide coming soon. I love these little like Raspberry Pi that just boots up, it just does one thing. And what's interesting is it's a Chromium kiosk mode player. So it's actually an X11, it loads up X, it immediately loads Chromium, puts it in kiosk mode, and then makes it square. And what's interesting to me is like playing a YouTube video is one of those things that's like very easy and natural to do on a computer or a phone or mobile device, but of course it's impossible for a microcontroller. And this is exactly where the Raspberry Pi is perfect. Like you want something that can just read a couple buttons, like the joystick for volume, and I can if I go right, it goes to the next video. Like it has a couple streams it'll play. Yeah. This is like a perfect use for like a Raspberry Pi where you want it to just play a little video, get audio from the internet, like playing a YouTube video, and you maybe have some buttons and maybe have like audio output from the speaker. Yeah, it's an appliance. It just like it's like it just does one thing. You can make things with it, which I kind of like. I want to try to find projects that aren't just playing retro games. Not that there's anything wrong with playing retro games, but other projects. So this will be a guide coming soon.
Okay, here's another question.
Yeah.
Can you recommend a circuit for powering a simple micro from a 5-volt USB or 5-volt external, or can I just do that with diodes?
Well, if it's a 5-volt microcontroller, you can just power directly from the 5 volts. Yeah, if it's a 3-volt microcontroller, and you're using a breadboard or something, you can then use like a through-hole 3.3 volt regulator. They're like 50 cents, per piece. They're pretty cheap. And then just use 2 capacitors on the input and output, and you've got power from USB. USB is great for powering stuff. Just don't use the data lines. It'll give you 5 volts up to about an amp.
Someone mentioned buck converter.
You can, but if you want to make it, if you're thinking about diodes, it sounds like you want to go simple and cheap. I would just get like a through-hole LDO and like 2 electrolytic caps. You can do it on a breadboard. I used to do it all the time. No biggie. All
right, what else you got going on?
Okay, so we've got this unfinished. I was like, I'll finish it before the show, and I didn't. But I have this new Ken M4 feather that we fabricated this week, and so I'm going to put it in the store hopefully this week. We ran out of time to finish prepping them. But it's a CAN bus hardware-supported chip. So instead of using like an SPI to CAN bus converter, it has CAN bus support natively. It actually has 2 CAN buses in it, although that's a secret that I haven't talked about. There's actually 2 pins over here that can do CAN on a second bus, but they're being weird, so I'm not publishing that yet. And then you have a terminal block, and you can wire these up together. I'm gonna have a little demo where like one potentiometer changes the LED on the other, and like vice versa. But these two, can connect together over the CAN bus port. And it's like a nice compact, like all-in-one feather, and it's pin compatible with the Feather M4, because the Feather M4 is basically like the lower grade version of this chip that doesn't have the CAN bus. So it's like it's the same pinout, like everything from like here back is the same. Other than I changed this to USB-C, and I tweaked the power supply a little bit to improve it, but it's pretty much the same. And then it's CAN bus from here on out. So that's kind of cool. So as I was doing this, I needed to spec a CAN bus transceiver, and I did get one, but I think I might want to find another one. I don't know why I picked the one I did in the end. It was chosen like a year ago in the before times. But let's go and spec a CAN bus transceiver on the Great Search.
Time for the Great Search. And do you want to do that question that I got, or do you want to?
That the question is, well, okay, let's
let's just kick off the Great Search.
Let's kick it off.
Here we go.
Where in the world is that part I need? The Great Search with Digikey.
Every single week we do the Great Search, brought to you by Digikey. Thank you, Digikey, for helping us do this show and so much more. We got a question on one of our last Great Searches from Erin. We know Erin, Robot Girl, and Erin says, what would you recommend for part selection when it has less than 100 in stock? How can you tell if the part is being discontinued or just waiting more to come in. Really like the series, find it super valuable to learn these tips and tricks. Keep it up. LADYADA, what's the answer?
Well, we're going to cover that today because coincidentally, maybe, the part that I'm going to be searching for isn't in stock. And so let's see how to, well, first off, we'll find some alternatives, but we'll also see to figure out, is this part ever coming back in stock? You know, you don't always know, right? Sometimes parts are discontinued. I'll give you some tips and also how to tell when it's going to come back in stock. It used to be a little easier to find on Digikey, but you can still find that information if you're sneaky. So let's do this thing.
Sneaky time. Okay,
so we're going to get a CAN bus transceiver for the SAM-E51 feather board that I've designed. The SAM-E51 is a 3.3 volt microcontroller. CAN bus is really ancient. It's like MIDI-ish. It's like this very old, simple, but very popular and effective industrial protocol for sending and receiving messages. There's like extended versions, there's like high-speed versions, whatnot. But basically it uses 5-volt differential signals. I'm still not 100% sure why sometimes you can get away with 3-volt differential signals, but it seems like everybody kind of wants, especially if you're doing automotive, you really want to do plus or minus 5 volts. That said, your microcontroller is going to be 3 volts, so it's one of those like 3 volt data, but then out here it's 5 volt data. So you want a chip that can kind of handle both, you know, like peanut butter and jelly go great together. 3 volt one side, 5 volt on the other, keep them safe, but also have that nice big differential voltage so you can send and receive messages even in very noisy situations like in a car. So the first thing I do when I want to spec a part that goes with another part is I actually look at the Eval Board, because the Eval Board, now first off, it's not unusual the Eval Board is going to use parts that are from that company, so it's not necessarily always the best part, but it's at least a part that you know is going to work. So in this case, you go to your microchip site. They have for this chip the SAM-E54 Explain Pro. The SAM-E54 is like even better than the SAM-E51, but it has Ethernet, but basically it's the same chip. Just has this extra peripheral. And in documents, you can download the user guide, which I did. And one of the most frustrating things about CAN is like searching for the word CAN is very difficult because the word CAN is used in English a lot. However, you get eventually to this section where they talk about it and they say, okay, it's connected to an ATA 6561 physical layer transceiver. That's the thing that converts the RX and TX 3 volt signal to the plus or minus 5 volts, like it's like dominant recessive or something. There's some wording that they use. So this is their chip. So again, not too surprising. This interface controller is from the same company. That's not a bad thing. I mean, I'm not against it. I sometimes mix and match in a design, but there's nothing wrong with also just going with the supplier themselves. And then in these documents, you can look at the data sheet. High speed CAN transceiver, communication speed up to 5 megabits per second. One thing that you'll want to, I don't think I have the SAM-E51 data sheet open. Hold on. I forgot. But the SAM-E51 data sheet implies that the CAN bus controller is, it can do like a 1 megabit per second, or it can do up to 10 megabit per second. So it's like you can do quite high speeds. So that's something. Oh yeah, wait. So this is the data sheet. I did have it open. Yes, if you find the CAN bus controller, it can do CAN FD, which if you like search through 2,000 pages, it does say somewhere like, oh, it can do up to like 10 megabit. And this transceiver can do up to 5 megabits. So that means it's just like, okay, if you're going to find an equivalent one, you want to have it about that speed capability. The other thing that you'll see is basically the voltage, the the protective voltage input, like how much voltage it can handle before failure. It's usually like 60 to 70 volts, depending on your industrial requirements that might be important to you. There's two package types. These tend to come in SOIC, and there's two very similar but not quite the same pinouts. So you'll notice that they have TX and ground and VCC and RX, and then standby, CAN H, CAN L, and then this one has like not used, I don't know what NCL is, and this has VIO. VIO is on this 6561, and that is the version that can handle 3 to 5 volts logic. So that's what you want. We want the one that's the 6561. So you have to be careful. Sometimes part numbers, they're shared in the same data sheet, but that doesn't mean they're equivalent. This one in particular, we definitely only want the ATA 6561. So knowing that, let's go back to Digikey. Don't forget to sign up and get some ESP32-S2 chips, the FR01 and the FH chip that just came out. And then in transceivers, we can see, yay, there's transceivers. There's the ATA 6561. That's what we wanted. However, some bad news. This version, the DFN, the small chip version, is in stock. You can see by mousing over, it's like teeny, it doesn't have the pin sticking out. And my design is kind of already done, and it's for SOIC. So let's go here. Okay, well, we can look for an equivalent, and maybe I'll show an equivalent, how to do that really quickly. But you'll see there's 0 in stock, and I'm impatient. Especially, here's another thing to watch out for. You see this, the manufacturer lead time, 30 weeks. Now, right now, at this moment in time, every manufacturer is having totally nutty lead times because all over Asia there's lockdowns and factories aren't open and things are very difficult to do due to government restrictions for COVID-19. However, just because it says that, that's the worst case. If you said I need 1 billion chips, how long will it take you? They're like, well, we'll get it to you in 30 weeks. That doesn't mean it's going to take 30 weeks for it to be in stock. So watch out for that. It's the max, the min-max, right? It's the worst case. So here's what we do. Now, it used to be visible here, and it's not. But what you can do is you can put 1,000 or 100 in stock. You add to your cart. And I already had some in cart, so we can change this to 100. And then you see here, oops. Sorry, I had a duplicate. It says here it's a back order, and then there's this little thing here that says check lead time. That's the sneaky thing. So click that. And it will tell you when they're expected to be in. So they're expected to be in stock around the end of the year. Now, that's also it's often quite true. I found that the lead times are a good guideline, unless there's some catastrophe that occurs. If they say that they're going to have a shipment to Digikey on 12/31, they're probably going to get it to them at around 12/31. So I wouldn't bet my manufacturing line on it. If I absolutely needed to have it, the next day, I wouldn't trust this because, it can vary. There can be shipping delays. There can be a storm. However, it just means will this ever be in stock again? Yes, in a couple weeks. So that's a good thing for me to know if I'm thinking about using this in my design, when I can get more. So I actually use that tool all the time. I'll put stuff in stock that isn't in stock into my cart just to get an idea of how long does it take for this to get back into stock, so I can kind of plan out my manufacturing runs. If I have a sensor I want to get and it's out of stock because everyone bought it up, when are there going to be more? I can do that, and I can say I don't have to rush my PCB design because they're not going to be in stock until at least late December, for example. So that said, don't forget, if you want to get an equivalent part, you can always go down to the product attributes and then click the things that you want to match up, and don't be too picky, but be specific enough that you can get the item you want. So you want it to be an active CAN transceiver with one RX and one TX. We want that same pinout. The voltage supply and temperature I'm not going to click for reasons. However, I do want it to be the same package. And then there's only 40 remaining similar. So that's actually kind of nice. It means I can pick out which ones. Now that AT6561 was 5 megabit per second. So I might want to select that. And then the voltage supplies, again, those are, don't believe those. Because again, there's the voltage supply of the CAN transceiver, which is about 5 volts. And then there's the reference voltage that you'll use for sending data back and forth. And then, so you will have to look at the data sheet. And then I want the ones only that are in stock. And then it looks like there's a couple options I can get from maybe the TJA 1044. I can also be less picky about some of these things. Like if I want to, for example, instead of protocol, I'll tell you why. There's CAN and there's CAN. Oh, interesting. They selected multiple. There's CAN and there's CAN bus, which like I wish they would be merged together, but they're actually two separate categories for the same thing. And then I can, sort by price, or I can sort down by stock to see which ones have the most stock. So there's like a lot of like these transceivers. The TJ or whatever 1051s, those are basically equivalent, and that's actually ended up what I used on my design. One thing that I have started to do, I prefer not to buy from Marketplace. I want stuff to come directly to me from Digikey. In Rochester, it ships from Digikey. So if you want it to ship at the Digikey speed, like the way, I don't know, I'm picky about that, you can unclick the Marketplace products. And then, like this transceiver is a high-speed transceiver. This one's from NXP instead. Obviously Microchip won't use this on their dev board because they're going to use Microchip. However, when you go down to the specifications and the pinout, you'll see it's like exactly the same. So this pinout is, wait, is this exactly the same? Hold on. Yeah, TX ground VCC RX, TX ground VCC RX, and then standby high-low VIO, standby high-low VIO. So you can use this basically as an equivalent drop-in replacement. There's a lot of transceivers. To pick the one that has basically the safety margins you need. But what I'll probably do is come up with a list of a good 3 or 4 of these that are equivalent, and that way, as I'm going through manufacture, if one is out of stock, like that ATA series, I can always sub in a TJA 1051 instead. Very wise. Always tell people when they're designing to have multiple sources for chips. I have seen many companies not bankrupt, but get very close because they are waiting for a chip that they couldn't get, and they were out of stock for months and months and months. You don't want that to happen to you. It can kill you, because if you have all but one part to manufacture, you have nothing. That's my wisdom for the day. Always make sure you have a backup plan for parts.
All right, and that's this week's Great Search.
Yes.
Where in the world is that part I need? The Great Search with Digikey.
Come for the knowledge, stay for the jingle. Okay.
Okay.
Here is a question. Speaking
Yes.
of things like the M4 Feather CAN bus, the Feather guide seems strongly to recommend against powering feathers over pins. Where I live, a LiPo won't last in my car over the winter, and powering over USB feels clunky for a permanent install. Should I heed the warnings? Any plans for an external power wing?
If you need to power something for a very long time, you always have the USB port, and that's why I don't have a pin input. You can, use a LiPo for battery, but if you're in a car, you can then use they have these little USB ports that plug in. If it's an older car, you can plug in a USB port into the cigarette lighter, or newer cars have USB ports built into them. just plugged into that USB port, and now it's powered all the time. And then you can have a LiPo as a backup, and then when the car is on, it charges up the battery, and then in between it can run off of the battery, and you can pick a pretty big LiPo. I mean, there's like 4,000 milliamp hour. We have like 7,000 milliamp hour LiPo batteries. If you use like a sleep mode, that'll last you a very, very long time.
Okay.
But USB, that's why I just tell people, like, just use USB, because like everything supplies USB power these days. That's how you should power stuff if it's not from a LiPo. Anything else is risky. Not recommended.
Okay, someone says, I got the Maximum Integrated Essential Analog Toolkit. Thanks for making the video about it. I'm still trying to think of good project ideas using these components. Cool. So you got the 3 parts.
It's free stuff.
Yeah. All right.
How you say no?
Okay, with that, that's our show.
Thanks, everybody.
Week. Little public service announcement time.
Okay.
Just as always, hey folks, just for like the next 60 days, just really watch your distance. Please wear masks. And there's so many things ahead. You like science, you like engineering, you're watching the show where there's a bunch of people that are kind of like us, but they work on virus defeating things like vaccines. And they're really smart and they did it. And just hang in there. So like there's just some things that you just got to do just for a little bit longer. Hang in there. And if you're the person in the family that everyone says like, oh, what printer should I get? What computer should I do? They trust you for that type of knowledge. Just make that phone call, send an email, postpone if you can those holiday plans, and just get through the next 60 days because we so much want to hang out with everybody, see everybody next year, and there's only one way to get there, and that's just being safe just for a little bit longer. I know you can do it.
There's all sorts of fun online activities you can do. There's Google's Advent of Code. I think it's available in Python if you want.
We have a show almost every single week.
We have tons of shows. We have lots of projects.
So you just got look. Wonder Woman's coming out on Christmas Day.
There's Did You Wish?
All sorts of things
do
are
that
going
every
on.
day.
There's all sorts of things going on,
Yeah.
and you can hang in there. So just do that because we're all in this together, as they say. But this is now the actual time that we have to fulfill that promise. Okay. That's it.
All right,
We'll
thanks
see everybody during the
everybody.
Yeah.
Hope you had fun.
Take care.
Good.